have the second theorem, I'll give you the other two form of this theorem. What we are having here is the angle which an arc subtends. That is an arc. I'm defining the arc in this case. Can you see it? An arc. Some of you are having problem with all of these things, and because maybe when I explained circle, you didn't pay attention. I've made it in a video, so go and watch. So what we are having there is that the arc there is what is saying is carrying a particular angle at the center. See the angle that is carrying. In our definition of this theorem, the angle that it carries that is of our interest here is the one outside. That's what I'm telling you. If you are giving this one inside, you cannot use it for this theorem. It's the one what? Outside. So the angle which an arc subtends or carry, the angle which an arc, this is the arc, the one that it carries at the center of the circle, as you can see it, at the center of the circle, is equal to twice, 2 times, the one that it carries, the one that it subtends at any part of the what? Circumference. You can see in this case, where it's not looking very confusing is that in the other ones, you see that it was projected from the top of the angle that is at the middle, right? But this one is now as if it's going inside again, but it's at the circumference. Don't forget, it's at the circumference, because what it tells us is that at any other part of any part of what? Circumference. So in this case, this angle at the circumference, which is this one, which is this angle now you are seeing, this angle at the circumference is resting on this same arc. It's a unique form of this theorem. We have 3 of them. I've given you one, I've given you the second, this one is the third one. So if, for example, I gave you something like, okay, let me just give you an example of here is 230 now, for example, 230 degree. If there was 230 degree and you are asked to look for x here, maybe I would have even solved example in the other one just now. Sorry, I wanted to put degree, I put 230 degree for instance. Now, if you have something like this, in this case, what you do is that, don't forget, you bring it back to theorem. Our theorem is 230 equal to what? 2 times, I can call here x now, which is what? 2 times what? X. Because I've labeled here as x. I'm no longer using it as alphabet angle representation. So I'm now having 2x, I can write it like this also. Over equal to 230, where you know our x, our simple equation. We now have 230 divided by what? 2, which gives us what? If we go here, 2 into 22, will give us 11. You made that one, put that one in front of this, we now have what? Right. So you will see that our angle, which is x, is now what? 115. So that is what the law is telling us. The same thing will apply for other theorems. I mean, for this same theory in that different form that we talked about. That is why you see that I consistently use what? BOC and what? BAC in all the theorem I've explained. So when you go through them, it's just very simple. We will solve questions, no doubt, but just understand the theorem. That's the essence of what I'm explaining now.